Topic 1.3, measuring line segments. We can use the properties of a square to find its area or its side length. The area of a square is equal to the length times the length, or the length squared. When the side length is L, the area is L squared. And when the area is A, the side length is the square root of A. To demonstrate those two formulas, let's take two squares. In this case, we are given the side length, which is 6, and we want to know what the area is. The area is going to be equal to the length squared. So we're going to take the length, and we're going to square it, and multiply it by itself. So 6 times 6 is 36 centimeters squared. Okay? If we're given another square and its area, and we're interested in finding out its side length, then the side length is going to be equal to the square root of the area. So in this case, that would be the square root of 49, which is 7. So the side length of this square is 7 centimeters. So if we're given some line segments on a grid, and we think of them as being the side lengths of a square, then it's really not a big deal to determine their length. Okay, we can actually draw the 3 other side lengths of the square. Here's one way you can do that. You can figure out what the dimensions of the line segment are. Okay, so this one, for example, goes 2 units over this way and then 2 units up. So I can just complete the square following that same pattern, forming what is called an enclosing square. I'm going to go up 2 units and I'm going to go over 2 units. Okay, I'm going to put a dot there to mark my spot. I'm going to continue following that process. So I'm going to go over 2 units and down 2 units. Okay, I'll put a dot there too. And then if I've done this correctly, I should end up back where I began over here. Okay? And a good way to just keep in check whether or not you are on the right track is to see if your enclosing square actually is a square. It should make a perfect square here. Okay? So it looks like we're on the right track. So what I'm going to do is I'm just going to connect these dots. All right, I'm going to make my square. You'll notice we have a tilted square here in the middle, but we have 4 triangles on the outside. So what we can do is we can look at the enclosing square. All right, it has a side length of 4 units. Okay, so if its side length is 4, then its area is going to be 4 squared, which is 16. That's the area of this large purple square. Okay? Now remember, we're still interested in this length here. But bear with me, we're getting there. So we have this area now. Now we have 4 triangles, okay? And these triangles are actually not even part of this tilted square in the middle, all right, that we made out of that line. They're not part of it, so we really want to get rid of them. Now, you remember the area of a triangle is base times height, okay, divided by 2, because a triangle is actually exactly half of a quadrilateral, or a rectangle, right? So, base times height divided by 2. Now, take a look at one of these triangles now. This triangle here, for example, it has a base of 2 and a height of 2. So in order to find out its area, we'd say 2 times 2, so the base times the height, divided by 2. So that's 4 divided by 2, which is 2. 4 divided by 2 is 2. Okay, so this triangle here, pardon me, has an area of 2. Now, we have 1, 2, 3, 4 triangles, okay? 1, 2, 3, and 4 triangles here. So what I'm going to do is I'm going to account for all 4 of these triangles by multiplying that area of one of the triangles by 4 triangles, right? We have 4 of them. That means the total area of all 4 of these triangles is 8. Okay? Now, our original enclosing square had an area of 16. So we're going to take this 16 and we're going to subtract the areas of these triangles, which add up to equal 8. That's going to give us a total of 8. So what this is telling us is that this tilted square here that we made from this blue line has an area of 8. Now remember our formula, when we're given the area, okay, and we want to find the length, we find the square root of the area. So that means that the length is going to be equal to the square root of the area. And in this case, we've said that the area of that tilted square in the middle over here is 8. So the square root of 8 is going to be the answer to the question, what is the side length of this blue line? Now I moved that last step for question A up here just so we can move it out of the way and have some more space for question B. So let's suppose we're given an additional line segment on a grid and we're asked how long it is. Remember, just thinking about it as the side length of a square can help us. So what we'd like to do is visualize this as the side length of a square, and we want to complete a square out this way, find that square's area, and then find the square root of that area to determine the side length of the square. Okay, the first step is to look at the dimensions of this line. Okay, it goes down 3 and then across 2. So what I'm going to do is just follow that same pattern. Down 3 and then across 2. I'm going to go out this way, 3, and up this way, 2. I'm going to continue that. So 1, 2, 3, 1, 2. Okay, and if I've done it correctly, I should be able to go this way, 3, and then down 2. Looks like I've done it correctly. Let's see. Yes, over 3, down 2. And what you can do to double check, if you recall, is just make sure that your enclosing square, so the square that encloses your tilted square, is actually a square itself. It's going to go a long way in helping you. So now we have to determine the area of that enclosing square and then subtract the areas of these triangles that we don't want to find the area of our tilted square. Okay? So this has a side length of 5, and our area is going to be the side length squared. So that would be 5 squared, which is 25, right? 5 times 5 is 25. Now, let's have a look at our triangles that we don't want to count. This triangle has a base of 3 and a height of 2. So we're looking at our triangles now. Make a little heading there to organize my work. That triangle has a base of 3 and a height of 2. And I'm going to divide that by a 2 because that is the formula for the area of a triangle. Right? Base times height divided by 2. So that would be 6 divided by 2, which is 3. So each one of these triangles now has an area of 3. And there are 4 of them. So I'm going to multiply the number 3 by 4 to account for all 4 of those triangles that we want to get rid of. So we want to get rid of 12 square units from the enclosing square's area, which we determined to be 25. So 25 minus the 12 for the triangles is 13. All right, so 13 is the area of this tilted square in here that has this blue line segment as its side length. That is 13. So its side length, following this formula, okay, is the square root of the area. And in this case, the area was 13, so the length of that line is the square root of 13.